Hi, my name is Amer Jaafar. I am going to introduce to you chemistry course which is related to grade 12 life and general science. In this course we are going to discuss main concepts related to the curriculum. We will try together to avoid and to discuss with you the main points and to avoid any misconception related to the concept. And in addition, we are going to solve problems together in order to be 100% sure that everything related to the curriculum is clear and we satisfy the objectives. In case you have any problem related to the material, we can have extra session and we can discuss these concepts together by live sessions later. In order to understand the curriculum this year, the curriculum will be divided into 3 parts. We have the physical chemistry part, the analytical chemistry part, and the organic chemistry part. But before start talking about the curriculum of grade 12, we have to introduce certain concepts which are considered to be the major concepts that we are going to use through this course. The main concept that I will introduce with today, it's going to be about the revision session. In this revision session, we will discuss the main points from grade 10 and the grade 11. And in fact, we need these in order to understand how to deal with problems and how to discuss the materials of grade 12. Which implies that the first thing that we will introduce it is stoichiometry and solution. In this video or in this lecture, we will introduce the concept of stoichiometry. In the coming session, we will talk about solution, and then we will solve a mixed exercise in order to clarify everything related to the concept of stoichiometry. Before start talking about stoichiometry and about solutions, we have certain relations that are a must, that you must understand how to deal with each. These relations are N equal mass over molar mass, N equal V over V molar, and N equal N over Na. In reality, we have to know that always small n represents the number of mole, small m is the mass, capital M is the molar mass, V is the volume of the gas, V molar is the molar volume of the gas, and usually you have to put in your mind that it is a temperature and pressure dependent. And the last one, capital N, is the number of particles, and Na is Avogadro's number. In addition to these 3 rules, we have C equal N over V. This is expressed in mole per liter. C is the concentration of the solute in this solution. N is the number of mole of the solute, and V is the volume of the solution. What you have to put in your mind, the rule N equal V over V molar is limited to gases. The rule C equal N over V is limited to solution. Now this is the main concept that we are going to talk about. Now we have to understand this fact. What do we have here? We have any chemical reaction can be expressed as A plus B, it gives CC plus DD. What you have to put in your mind that A and B are called reactants. C and D are called products. And the small a, small b, small c, and small d are called the stoichiometric coefficient. You have to put in your mind that these stoichiometric coefficients are going to be obtained by balancing. And therefore, when we balance the chemical equation, we are going to satisfy the law of conservation of atom. And when we satisfy the law of conservation of atom, we will be able to find these small coefficients A, B, C, and D. Now, my target in this session is to introduce the types of mixtures when we are going to say in chemical reaction mixtures, I am going to discuss two types, stoichiometric mixture and non-stoichiometric mixture. When we want to discuss stoichiometric mixture, we have several rules and steps we must follow. Therefore, the first mixture that I want to introduce is the stoichiometric mixture. Step number one, I will assume the reaction that I will study here is 2A plus B, it gives C. My advice to you, always you have to keep in your mind these relations, because without this relation, you will not be able to understand how to start solving any problem in chemistry. Now, I want to check whether the mixture is stoichiometric. What is the first step? We must determine the number of mole of A and B. How do we determine the number of mole of A and B? Using one of the following relations. 2, we must find the ratio. And when we say the ratio, it means that I want to find the ratio of A and the ratio of B. How do we find the ratio of A and the ratio of B? It is the number of mole of A over its coefficient. يعني N of A over 2. والratio of B, it is N of B over 1. Now the condition for the mixture to be a stoichiometric mixture is to have the ratio of A equal the ratio of B. If the two ratios are equal, directly we write the mixture is a stoichiometric mixture. Now what is the importance of the term? نحن هون we are talking about chemistry, about science, not about mathematics. In mathematics you deal with numbers without understanding or without giving definitions for them. But in science, each number is going, or each relation is going to have a scientific meaning. What is the scientific meaning of a stoichiometric mixture? It means that we have total consumption of reactants. It means that at the end of the reaction, you do not have either A or B. Therefore, A and B are totally consumed, which implies that at the end of the reaction, what do you have? All of you are going to tell me that we have C. بس please يا حلوين, it is not enough to say C. We must understand the expression that we will use. C is a product. A product, we will use with it the term formed. This implies that at the end of the reaction, we have C, but it is not enough to mention C. We mention C formed, and this is the first term today. Formed is used for a product. How do we find the quantity of C formed? The quantity of C formed is going to be found from A or B according to stoichiometry. This implies that N of A over 2 equal N of B over 1 equal N of C over 1. And this is how are we going to find the number of mole of C using any of the two reactants, A or B, because we have them as given from the beginning. And this is the meaning of the first mixture, which is stoichiometric mixture. Now, if I want to understand more, how to repeat this in another way, a reaction A plus 2B gives C plus 2D. A and B, as I said, the reactants, C and D are the products. The 1, 2 are considered to be the stoichiometric coefficients, and any chemical reaction can be either stoichiometric or non-stoichiometric mixture. I introduced what is the meaning of stoichiometric mixture, and as I said, a mixture is said to be stoichiometric What are the steps? In order to check if the mixture is stoichiometric or not, we find the ratios of A and B. What is the condition to have a stoichiometric mixture? The two ratios must be equal, and there will be a total consumption of reactants, which implies that the chemical species at the end of the reaction are C and D formed. It's very important to mention the term formed. And as I said, we can determine the quantity of C and D using the concept of stoichiometry, and this is the relation where we can find the quantity of the products C and D. This is if the mixture is a stoichiometric mixture. Let me move to the second type of mixtures. The second type of mixture is non-stoichiometric. Here, please pay attention, and usually this is what we are going to have in almost all the problems. Similarly, we will determine the ratio of A, which is N of A over 2. Ratio of B, it is N of B over 1. Similarly, A, 2A plus B gives C, and the same equation. Here, for the mixture is to be non-stoichiometric, it means the ratio of A different from the ratio of B. Any inequality means that they are not equal. شو يعني they are not equal? It means one greater than the other. Let me assume in this that ratio of A greater than the ratio of B. What is the physical meaning that ratio of A greater than ratio of B? It means that B is the limiting reactant and A is in excess. Now let me define terms, and I told you that we are taking a course in experimental science, not a course in mathematics. And therefore, we must always define terms, because if you will not define terms, you will not have the opportunity to participate in. Yani from now, you will define love, so that in the future you will be able to live how to participate in the term love. You will define what is a father, what is a mother, in order to be able in the future to participate in the term. Similarly here in science, بس تسمع limiting reactant, it means that totally consumed. Once you are going to say excess, يعني we have a remaining quantity of it. Okay? Therefore, in a non-stoichiometric mixture, what are we going to have? 2A plus B gives C. B is the limiting, يعني it will react completely, which implies that what do we have at the end? We have C formed, please pay attention, and A new term remaining. Why we care about the remaining? Suppose that you have $100. You are going to buy a product for $100. I will ask you, how much do you have? You will not tell me, wallah, I paid $10. You will tell me, I have $90. Therefore, for the reactant, what you care about قد ايه معك مش قد ايه صرفت, the remaining quantity, not the reacted quantity. Therefore, A remaining. Now my target here is to teach you how to determine these two. Now here you may have a certain confusion. Mean that the one that will control this reaction, mean when it finishes, the reaction will stop. Limiting, يعني limiting هو الكي تبعي to find everything. Therefore, I can use a limiting to determine the quantity of C formed and the quantity of A, but using the concept of stoichiometry. طول بالك. بيقول لي واحد using the concept of stoichiometry, you are saying that the mixture is non-stoichiometry. How come we will use stoichiometry and the reaction is non-stoichiometry? Let me introduce this fact. What is the meaning 2A plus B. حبيبي بس تسمع كلمة 2A plus B, it means that the proportionality of the collision between these reactants to give product is according to this coefficient. It means each molecule of B will search to collide with two molecules of A. Therefore, the collision that will take place at the microscopic level between 1B and 2A for the reaction to proceed. Suppose that you have 1B or 5A. If you have 1B and 5A according to the proportionality, this is non-stoichiometry لأنه نحن we said each A, B, it needs 2A. Therefore, here we have 5A, the mixture is non-stoichiometric. Although the mixture is non-stoichiometry, when the reaction will take place and B is going to search for A to collide, it will search and collide with 2A. And therefore, we have remaining 3A. And what you have to put in your mind, although the mixture non-stoichiometry, but the collision will be always according to stoichiometry. Therefore, each molecule of B will collide with two molecules of A according to stoichiometry, and these are remaining. Which implies that even though if the mixture non-stoichiometric, the reacted that they will react according to stoichiometry. And this implies that how are we going to solve the problem here? We will say that N of C formed over 1 equal N of B over 1 equal N of A reacted over 2. Therefore, when A, B will collide, it will collide only with the part that will react. Yani the one will react with 2. This is the collision. These 3, they will remain. And therefore, from B, we will be able to find the quantity of C formed and the quantity of A reacted. But my target is not to find the reacted. My target is to find the remaining. And what is the remaining? It is the total minus the reacted. Therefore, N remaining equal N initial minus N reacted. This reacted is using stoichiometry. This one is given at the beginning, and therefore I will be able to find the remaining. Let me summarize all of this. If I will summarize this, I will summarize it here. Now, pay attention. If the mixture is a non-stoichiometric mixture, we are going to determine the ratios, but here the condition is the ratios are not equal. We will consider ratio of A greater than ratio of B. What is the meaning that the ratio of A is greater than the ratio of B? It means that A is in excess, B is limiting. Therefore, if B is the limiting, what do we have at the end of the reaction? We have the A that will remain and C and D that are going to be formed. How can we determine C and D formed? C and D formed will be determined using stoichiometry, but نحن we said min الكي, the limiting reactant. فإذا from the limiting reactant, we will be able to find the quantity of C and D formed. Here what we have to pay attention to, the remaining quantity will be determined according to the following relation. We said N remained or N excess equal N initial minus N reacted. Ya Sabaya ya Shabab, this reacted, how are we going to find it? We will find it from the limiting reactant. And therefore, I was able, according to this relation, to find the reacted quantity according to stoichiometry, and form the quantity according to stoichiometry, which implies that in chemical reaction we have 3 terms. 2 terms for reactant, 1 term for a product. Product formed. خلاص. كلمة product, we use the term formed with it. Reactant, we have 2 terms that we have to pay attention to. Remaining and reacted. Reacted is always according to stoichiometry. Remaining is always initial minus reacted. And this is how we find the composition of the mixture at any time or at the end of the reaction. Once you hear the term composition, يعني determine everything at the end of the reaction. The last concept for today will be how to find this composition but using something else, using the concept of table of variation. هلا, before I continue, let me introduce quickly this term, and then we will summarize and finalize the lecture today about the descriptive table. We said to determine the quantity of reactants and the products, we use the concept of stoichiometry. But in the concept of stoichiometry, as I mentioned, عندنا reactant بدنا ننتبه remaining أو reacted, formed أو not, therefore we have expressions we need to use them. The beauty of this descriptive table is we will solve the problem as a mathematical problem. يعني we will deal with numbers without giving any expression. Let me choose a reaction. A plus 2B gives C plus D. In a descriptive table or table of variation, I'm going to mention the time scale. Always I care about initial time, what will happen with time, remaining at this time, and maybe at infinity, what will be my composition. Initially, this is something you are not responsible about. This is initially, it will be given. Given يعني it depends. هو بيقول لي we mix 1 mole 5 mole. Therefore, I will mix here 3 mole of A with 2 mole of B. And usually, we do not have products at the beginning of the reaction, and this is why the products will be 0 and 0. What will happen to the quantity of reactant? With time, reactant with time, they will decrease due to the reaction. Therefore, the sign that I will use will be a minus sign. What will be the sign for products? Because the products, they will be formed. Therefore, the sign here will be plus and plus. Suppose it 2D. Now, after 1 minute, are they going to be the same variation? يعني after 1 minute, 2 minutes, 3 minutes, are they going to decrease in the same way? For sure not. Therefore, I will assume that the variation of A is going to be a certain number x. If the variation of A is going to be a certain number x, B is 2 times A, therefore this one will be 2x. 2x not because of this 2, because of the coefficient that we have. The coefficient here is 1, يعني 1 to 1 ratio. If this is x, this is also what? This is also x. 2D, the coefficient is 2 times A, it is also 2x. And therefore, what will be the remaining? We will solve a problem about this later. X plus 2x. طيب. The term infinity, it means the end. And when the reaction is going to reach its end, when the limiting is totally consumed. Now, which substance is the limiting? I have to find the ratio of A and the ratio of B. Ratio of A, it is 3 over 1 equal 3. Ratio of B, 2 over 2 equal 1. Simply because the ratio of A greater than the ratio of B, it means that B is the limiting. And therefore, at the end of the reaction, the limiting will be totally consumed. Therefore, the value of B will be 0. And from this, I can find the value of x, which is 2 equal to 2x, يعني x equal 1 mole. Once you find x, you can replace x بالtable. x equal 1, يعني 2x equal 2 mole. x equal 1, يعني x equal 1. 3 minus 1 equal. Therefore, this is the composition of the mixture at the end of the reaction. This composition, we can apply the principle of stoichiometry to obtain it, or you can obtain it using the descriptive table. The beauty of this descriptive table, we will avoid expression, and therefore you will not mention reacted for the remaining. Directly, you are going to deal with the problem as a mathematical problem. To finalize the lecture here, I am going to show you how to deal with descriptive table. We have an, bn prime, 0, and 0. With time, minus, minus because reactant, plus, plus because the product. I assumed this one to be my x, so therefore this one will be 2 times this one. It means that minus 2x. The coefficient is 1 to 1, so the proportionalities are equal. So if this is minus x, this is the plus x. Or similarly here, if this is 2 times a. If this is x, this is 2x. Now suppose that a is the limiting. You can n minus x equal to 0, and you find the maximum value of x, which is n. And after that, you can replace x by its value, which is n, and find the values of a, b, c, and d at the end of the reaction. Thank you.